Okay, let's dive in. We're looking at higher order functions today, specifically in JavaScript.
Right. HOFs.
And these aren't just your everyday functions, are they? We're talking about functions that work with other functions.
Exactly. That's the core idea. It's fundamental if you want to write more, well, flexible and reusable code.
So this deep dive is really about getting what they are, seeing how they work, and maybe most importantly, why they're such a big deal for writing, cleaner, more advanced JavaScript.
Precisely. So fundamentally, a function earns the higher order title if it treats functions like any other value. Meaning it does one of two things. Either it takes one or more functions as arguments.
Like callbacks.
Exactly, callbacks. The HOF calls them back later. Or the second thing is it actually returns a brand new function as its result.
Okay, so functions using functions or functions making functions.
You got it.
We probably use the first type all the time without even thinking too hard about it, right? Like with array methods.
Absolutely. That's the perfect example. Think about map, filter, maybe reduce.
Yeah.
When you write, say, myArray.filter, some test function, you're handing your some test function over to filter.
And filter just runs my test on each item.
Right. Filter itself provides the looping logic, the iteration. It doesn't need to know the specifics of your test, only that it's a function it can call that returns true or false.
Okay, so it separates the looping from what the specific test or transformation I want to apply.
That's a great way to put it. It handles the general pattern. You provide the specifics via the callback.
Makes sense. Now the other kind, functions that return other functions. That sounds a bit more abstract.
It can feel that way at first, yeah.
Yeah.
But it's incredibly powerful, especially for creating configurable or specialized functions.
Like building a function factory. Is that a fair analogy?
Yeah, I like that. A function factory. Imagine you need functions that multiply by different numbers. 1 multiplies by 2, 1 by 10, whatever. Instead of writing multiply by 2, multiply by n separately, you could write one higher order function, maybe called create multiplier.
Can I tell it what number to multiply by?
Exactly. You pass in the factor, say 5. So you call create multiplier 5.
And what do I get back? Not the result of a multiplication, right?
No, you get back a new function.
Whoa, okay.
You could store it like const multiply by 5 equals create multiplier 5. Now, multiply by 5 is a function.
And I can call that function later, like multiply by 5 to then.
Precisely. And it would return 50.
But wait, how does that inner function, the multiply by 5, remember the number 5? Because the create multiplier function already finished running when I created it.
Ah, great question. That's where this really neat concept called a closure comes into play.
Closures, right. Heard of them.
The function that create multiplier returns essentially closes over the factor variable from its parent scope. It holds on to that variable, remembers it, even after create multiplier is done.
So it keeps that 5 foot tucked away somewhere.
Kind of, yeah. It maintains access to that variable from its birth environment. That's what makes the return function specialized. It's a really common pattern.
Okay, I think I'm following. Functions taking functions, functions making functions using closures. But let's zoom out. Why is this considered, a more advanced or better way to code? What's the real win?
That's the crucial part. It boils down to a few key benefits. Huge one is reusability. You're not writing one-off rigid functions. You're creating smaller, focused pieces, the HOFs and the callbacks that you can combine in many different ways.
Like Lego bricks for logic.
Sort of, yeah. It promotes composability. You can chain these things together. Think map, then filter, then reduce on an array. You're composing operations.
Right, instead of one giant loop doing everything.
Exactly. And that leads to code that's much more declarative. You focus on what result you want, not the step-by-step mechanics of how to get it.
So instead of writing out the loop manually, checking conditions, pushing to a new array, I just say filter this array with this condition.
Precisely. You abstract away the imperative boilerplate, the loops, the temporary variables often. This makes code easier to read and reason about, especially as things get complex.
Hiding the complexity. I could see how that helps.
And it ties into writing pure functions, too. The functions you pass into HOFs, like map and filter, are usually expected to be pure, no side effects, always the same output for the same input.
Which makes testing way easier, right?
Way easier. Pure functions are predictable. So using HOFs encourages patterns that lead to more testable, maintainable, and robust code overall. It's a Shannon thinking that really pays off.
Okay, so wrapping this up. Higher order functions. They either take functions as arguments, like callbacks for map or filter, or they return entirely new functions, often using closures like our create multiplier example.
That's the essence of it.
And the big deal is that this approach helps us write code that's way more reusable. You can compose pieces together. It's more declarative, saying what, not how, and often easier to test because it pushes you towards pure functions.
Absolutely. It's about abstraction and building flexible tools rather than rigid procedures. Mastering HOFs really is key to leveling up your JavaScript and functional programming skills.
It really changes how you approach problems, doesn't it?
Yeah,
Moving beyond just syntax to powerful design patterns.
it does. They are definitely a cornerstone. Which brings up something interesting to think about.
Yeah.
Well, if you start thinking of functions as things you can pass around, create on demand, combine, how might that change your approach to solving a problem you previously found really complex or messy? What could you simplify by building it out of configurable function behaviors instead?
Hmm. That's a good question to chew on. Something for you to think about as you continue your coding journey.